is Harry, and this is Physics Lab 4, Oscillations. To begin with, in this experiment, I analyzed and modeled the motion of a spring oscillating when released using the energy principle in Newton's second law. And unfortunately, due to a lack of time, my model didn't at all show the predicted motion. It was pretty bad. Um, so let's get into it. Assumptions. We had the mass of the object that was already given, and we had the positions that I got from Tracker from the video. Um, yeah, and also like I calculated the L naught, the unstretched length of the spring, using the equations given, and it's there in my code, as I'll show. Right here. It took some time, but here it is, right here. This is the mass. This is the initial position. I'm not really worried about the velocity. Um, Timing, gravitational constants are right there. Yeah, L naught and everything. Very nice. Yeah, these are formulas for the all the types of energy. They all equal the total energy. In this system, it's well, yeah, in this system, it's all going to equal to zero because no total energy. There's no like energy transfer going on. So this is the while loop for it. And I use the momentum principle and as well as yeah, momentum principle with the position update formula and the velocity update formula for these parts right here. Also, the spring force formula was used in my while loop. And I use this formula to calculate the energy changes. So back to the PowerPoint. Yeah, that's basically the initializations and edits I made for my code. Um, so the data, the meat of everything. So going back to my code, I'll run the code and I'll show what I ended up getting. So when I run my program, this is what I get. As you can see, this is not what it's supposed to be. It's supposed to at least somewhat follow where it's supposed to go. Where the red is the experimental. That's from the experiment. This is just not it. Um, yeah, not close at all. This is an example of what not to do. Um, yeah, so this should show that the energy principle is justified, but you can't really tell that from here. So, moving on. So, what does it mean? Let's get to the questions. So as I said before, the energy principle should be justified from my data. Unfortunately, my data is just terrible. But it should be like that because they're all supposed to add up to equal to zero. They all cancel out each other. Um, so that would have been reflected in the graphs. And so the second one, using tracker data, we had to make two estimates of the oscillation periods. So back in Tracker, I did this by I would find the period and like well in the from the video, I would just take it and like from like the third period, I just like divided it and for the y estimate, I got 1.456 seconds. For the x, I got 1.583 seconds. So the X is clearly larger. What does this mean? I can't tell you. Um, yeah. So I mean, that's about it. Like and subscribe. Thank you.